Download this code from codegive.com, link in the description below. Seed Labs Buffer Overflow Attack Level 2 Tutorial. Overview *. Buffer overflow is a common vulnerability in C/C++ programs that occurs when a program writes more data to a buffer than it can hold. This can lead to unpredictable behavior, including crashes, data corruption, and security breaches. This tutorial will walk you through a buffer overflow attack using a simple example, aiming to exploit a vulnerable program in a controlled manner. Objective *. The goal of this lab is to understand how buffer overflow attacks work and how an attacker can manipulate the program's execution flow by overwriting the return address on the stack. Prerequisites: 1. Basic understanding of C/C++ programming. 2. Familiarity with concepts like buffers, stack, and memory layout. 3. A Linux environment, or a compatible virtual machine, with GCC compiler installed. 4. Basic knowledge of using a debugger like GDB. Environment setup. 1. Create a C program *. We'll create a simple C program that contains a buffer overflow vulnerability. 2. Compile the program *. Compile the program with stack protection disabled. Understanding the code. Vulnerable _function *. This function takes a string input and copies it to a local buffer using strcpy. Since strcpy does not check the length of the input, it can easily lead to a buffer overflow if the input exceeds the buffer size, 64 bytes. Secret *. This is a function that we want to call exploitatively. Finding the vulnerability. 1. Run the program *. Execute the program with a long string to see how it behaves. 2. Using GDB *. Use GDB to analyze the stack and find the return address. 3. Inspect the stack *. Use the info registers and x/40x$ESP commands in GDB to inspect the stack and locate the return address. Crafting the exploit. 1. Determine the address of secret *. Use GDB to find the address of the secret function. 2. Construct the payload *. The payload needs to contain a buffer of 64 bytes, filling the buffer. 4 bytes of padding, to reach the return address. The address of the secret function. Running the exploit. 1. Pass the payload as an input *. Expected outcome. When the exploit runs successfully, the program should call the secret function, printing "you've been hacked," instead of "program finished executing." This indicates that the return address was successfully overwritten with the address of the secret function. Conclusion: this tutorial demonstrated how a buffer overflow can be exploited to alter the control flow of a program. This is a fundamental concept in understanding software vulnerabilities. Always remember to apply security best practices and mitigations, such as bounds checking and using safer functions, to prevent such vulnerabilities in real-world applications. Important notes: this tutorial is for educational purposes only. Always practice ethical hacking and ensure you have permission to test the systems you work with. Use modern programming languages and frameworks that provide built-in protections against buffer overflows.